Good evening, y'all. Welcome back to another Sunday night of electronics bashing. It's been a little while since we've done this side of things, but nominally, originally, before we got deep into Demulate shenanigans and then the holidays and everything else, every other Sunday night we talk about electronics. Originally it was Arduino, now it's Raspberry Pi. I know, we got fancy. Got a little video loop there. I don't know, it just seemed like a fun time to mix it up. Yeah, we're gonna have a good old time tonight. Tonight's topic is so originally, right? We did 18 weeks almost consecutively on Arduino programming and wiring electronics, and we sort of shifted gears to Raspberry Pi based stuff. And this is 7 or 8 of or 9 of the Raspberry Pi stuff, which is, it's been a little while. It's been like a month since we've talked about actual Raspberry Pi things. But one of the things I thought might be really useful to talk about is if your Raspberry Pi needs to be somewhere that's not right on, right on the desk in front of you, how are you going to have access to it to program it and get it to do what you want? So that's what we're going to talk about tonight. Lots of the familiar faces here tonight. Hi, Brooke, both. Nate, Chris, good to see you. James, a pleasure. Thank you for the sweater. Yes, we're like oscillating back and forth here in Chicago between like coat weather and sweater weather. Well, I guess heavy sweaters, coats, or coats plus sweaters. So found this one as I was digging through more warm options and feeling pretty fancy about it. So yeah, well, as always, let me know if things go wrong. If things go disastrously wrong and I lose the chat or something, you can always call the bat phone back here, the rotary red phone, at the number at the bottom of the screen, if that works. I'm going to try and remember to keep up with the, to-do list at the bottom of the screen here as I go. I didn't do that very well the first time I tried it, but we'll see how it goes. Hopefully that keeps me a little bit on track as we go through the evening, and as always, ask questions as we go, and we'll see. I'm not going to claim to know every single thing, but it's probably better that way. Yeah, Thomas, you should have. So Thomas was very helpful. Many of you were here for last night when I did an impromptu Demulite stream testing out some of the new LEDs and lenses I had ordered from China. And when I started up tonight's stream and started sending that to Google, it defaulted to the previous stream. It was like, oh, let's do new LEDs and lenses again. Thomas was right there in the chat, like, hey, unless you want to do more lenses, this is not where you mean to be. So thanks, Thomas. I appreciate it. Yeah, and next time you can just call me, although the chat worked pretty well there too. Yeah, we'll just dive in. Let me know, again, as always, it's hard for me to tell what the audio is like out there, if the music is too loud. I'm turning my gain down on my mic a little bit here because I can see myself peaking. Yeah, yesterday's schedule was fire, fire, fire. And we had a little smoke at the end, so we didn't quite stay on track there, but I feel okay about that for myself personally. Yeah, we used to do a countdown with, like, waiting for people, but I feel like it's, that time was taken up by saying hi to friendly faces now, so let's just get into it. What I want to talk about tonight, right, is this idea of we've been working with the Raspberry Pi, doing interesting things with it. It's a neat form factor. I actually have 2 Pis in the desk tonight for reasons that will become clear later. This is the Pi 4 we've been using for most of the classes. This is a Pi 3 I was actually given for Christmas, which came with this nice, nicest case that you can sort of still get access to all of the ports on it, and the power port and various things, the HDMI out there. But it's a little bit more robust, especially something in this kind of case, right? Like if you wanted to build an internet-connected, temperature sensor, weather sensor, maybe this box goes somewhere that's not on your workbench, right? Maybe it goes outside by the shed. Maybe it's even just like an air temperature monitor that goes on my ceiling or in the basement or who knows what. Let's say we wanted to, set it up, plug it into the network, and it just takes some measurements and sends them off over into the cloud somewhere. We'll deal with that some other time. Maybe it's MQTT, maybe it's UDP, something like that. But let's say you wanted to make some changes to the programming of it. One way would be to lug a mouse and a keyboard and a monitor down into the basement or the shed or wherever it is, hook everything back up, make your changes, save them, run your program, and take everything back down again. Maybe a better way is to take the Pi back to your workbench and reprogram it there, and that's also fine, but neither are strictly necessary. There are ways of configuring and interacting with the Pi, and really with any Linux system, the Pi sort of being our plaything, that do not require you to have physical proximity to the device, and we're going to look at a few of them tonight. Does the case of a fan? No, this one, Nate, does not. This is literally just a 2-part plastic case. There are definitely some with fans. Another thing this one doesn't have, you can see the Pi 4 has a little heatsink on the CPU there to help with throttling. This one does not. So when we really start putting load on it, I would expect it maybe to throttle a little bit as that heats up. But as they go through the generations, they get a little bit better about thermal management, and the 4 is actually pretty good to start with. So I'm not super worried. I'm also really not doing anything super intense with it. But a fair question. A lot of the sort of like more like run this as your main workstation cases do have fans. Yeah, so we're going to talk about, let me see here, according to, essentially, well, I don't know how to categorize it, 2, 3, 4 different methods of remote access to a Raspberry Pi over the course of the night. The first one of which is, as we load up the to-do list, I remembered one. I only have 4 on the list tonight. There's no nesting, no folders. It's just the 4 things you see below. So if I can remember to do this, hit that button 4 times, then all is well. Burpa says SSH is great. Don't bother setting up the GUI. Yep, just set up the Wi-Fi connection and SSH on the... Yes, so that's... SSH is where we are going to start this evening. And this is actually going to work out fairly well. So last week when we did the Demi-Light stream on a week that normally would have been like an educational night, that was because I think I referenced like the thing I was trying to like pull together and wrap my head around and just realizing I wasn't expert enough in or practiced in communicating enough was the fundamentals of the terminal, Git, and GitHub. And there's just so much ground to cover there that I felt like I was biting off more than I can chew for when I actually started to prepare the thing. But just talking about the introduction to the terminal, which will relate to the secure shell, and if both of those terms are new to you, that's fine. We will go over them just here. This feels like sort of chapter 1 of the 8-part book that class will ultimately be, if and when it comes out on one of these Sunday evenings. So let's pop over to the Pi here, and we'll talk a little bit about the terminal and the shell. If you are a Mac user, you may be relatively familiar with the concept of a terminal. I'm kind of cutting my terminal off there. There we go. Because you have a terminal built into Mac. Windows has the command line, which feels similar but doesn't really accomplish the same thing. And I will apologize in advance. I am going to, for all you nerd purists out there, and I know there's at least 2 of you, I am going to use the terms terminal and shell a little bit loosely tonight, or terminal emulator. To be picky about it, the shell is the system inside the operating system that's executing commands. What we interact with on the screen is a terminal emulator that's behaving in much the way that an old computer terminal or originally a teletype type machine would do to give us some ease of use features and easy ways of interacting with that shell-based system. So if we're gonna say, you know, shell, terminal, and what have, I'm gonna probably throw those terms around a little interchangeably, and I apologize. So what is the shell? What is the terminal, and how do you launch it? Well, if you're on the default install of our Raspberry Pi OS, you can click on the terminal icon at the top of the screen, or down here in, I think, accessories in the Pi menu, we get a terminal, and it'll open up like this. Now, I've blown my font up quite a bit and changed it so it's a little bit more visible on the screen. It will not usually take up quite this much space. The gist of a terminal or a shell, it's just another way of interacting with the data in a computer. If you didn't start using a computer until, the year, I don't know what year, you know, in the 90s, right, in the mid-90s, you probably are more familiar with the graphical user interface style of interacting with the files and programs on your computer. And the metaphor of the folder really is the dominant visual metaphor these days, right? We think of our hard drive being a big file cabinet of sorts within which are several folders, and each of those folders could have files in them, they could have nested folders, and so on. And when we want to interact with those files, move them around, see what they do, see what size they are, or modify them, we might use a separate program to do that. We might use a text editor, a word editor, an image editor, a sound recording editing software, all these various things. So this you know, file system that we're probably all relatively familiar with, whether on Linux or Windows or Mac, right? This is the metaphor that we use to identify, we think of this in many ways, like some of us literally think like this is how files are stored in the computer, right? They are in a named folder, and within that is a named file, and so on. And we use this sort of graphical analogy to the physical file systems that predated computers to help us conceptualize what's going on inside of a computer. The the terminal, I should say, is just another way of doing those same kinds of data manipulations, but instead of clicking and dragging and doing them visually, we do them through a text interface. And for those of us who are programmers, and many of you here are, I imagine, or here to learn to be, typing commands into a system to command it to do something will be relatively straightforward for you. It's like programming in a way. We'd call it scripting. We'd say, you know, hey, terminal, do this to the files in the computer now. Hey, computer, do this to that folder. Do this to that file. You might also say, hey computer, tell me about this file. Show me the text in this file. Show me this list of directories, and so on. This is going to be one of the ways we can interact remotely with our computer, rather than trying to get this whole visual environment to show up somewhere remote from the Raspberry Pi, right? Instead of having a sort of graphical user interface present remotely, we could have just this shell, just this terminal interface sort of push its data back and forth over the network, and that will be a very low bandwidth way for us to communicate with the computer and do pretty much anything we can do in a GUI file system we can do in the terminal. So what we're going to do first is look at some very, very basics of interacting with the terminal, and then we'll look at how do you do that remotely. So a little bit of a bait and switch, right? We're going to talk just a little bit about terminals, which could be, again, a whole evening or many evenings or books in itself, but just some fundamentals. I think this will also be a really useful thing if you like poking around in the Pi. James is not even the programming; he's just here for the lights. Well, James, thanks for joining us anyway. I hope you learned something tonight, or go poking around in some computers afterward. I think that'll be fun. What was I saying? Oh, one of the no, it's gone. Can't really have mattered. Let's look at the terminal. Let me get that screen out of the way here. Let's see. So, I'm going to introduce you to some very, very basic commands that you can use in the terminal to do things. And like I said, I think I'm looking at my cheat sheet here that I made. I think it's about a dozen, right? There are literally hundreds of commands that come pre-installed, and many more that you can install. But here are some basic ways, some basic commands you can use to move around the system. I remember what I was going to say. If you are monkeying around inside a Raspberry Pi, or looking at like web tutorials or like trying to install new programs, often they will have you use the terminal. They'll say, run this command in your terminal, in your shell. and it will do the things that I want you to do. And in some ways, for a web-based tutorial, that's really handy, right? Because I don't know what your graphical user interface looks like, or exactly what your folders are, or what your layout is. You know, I can't really rely on saying, okay, well, now go to the left side of the screen and click on music or download, right? Because I might have changed how this all looks. But by and large, shell commands are shell commands. And there are different flavors of shell. This one, the default one in Pi, is the bash shell. That's by far the most popular shell, B-A-S-H. Stands for the Born Again shell, B-O-U-R-N-E, Born Again shell. There was the Born shell, there's the Born Again shell. There are other shells, ZSH, KSH, but the bash shell is by far the most popular. So if, for example, if your web tutorial is like, hey, go and install these 3 pieces of software, it can be easier to say run, copy and paste this text into your shell, and I know it's going to work. Ooh, Brokeboth makes a very good point. GUIs can change quite a bit with updates. I mean, certainly the Pi and Debian have a lot. Command line interfaces are relatively static, and I would say there tends to be better about maintaining backward compatibility or throwing up a really big obvious error if they're not going to, right? Oh yeah, Chris, I didn't change the banner for the I guess it's over there now, for the Demulite website to the Electronics Bash website. I'm not going to worry about it too much, I think, tonight. Let's get into the terminal. We should start talking about a few things that you can do here. So, much like when you, and I'm going to do this by analogy with the GUI quite a bit, so forgive me, purists, you shell purists. Much like when you're viewing a folder in a GUI system, you are in a specific place in the file structure, right? Right now, I'm seeing the bar at the top of my window here says I'm in the /home/pi directory. If I go into the documents folder, now I am working in the /home/pi/documents folder, and so on, right? Just like we looked at that bar at the top of the screen there, we have a command that just tells us what folder am I working in, like where am I in the file system, and that very basic command is pwd, print working directory. When I run that, it tells me that it's also starting to default in the /home/pi directory. So we can always say, hey, where am I? pwd, print me the working directory. Now, it would be a lot nicer, though, if we could see, like, what's here, like what is in this folder. And there's another very simple command for that. It is the ls command, the list storage command. We hit that, and we get basically everything that is in our folder. What have I got here? Something back from some images that I created back on, some screenshots from the late October period, and a bunch of other folders. My terminal, and probably yours too, if you're running on the default shell on the Pi, will do some nice color coding for you, right? It's colored these magenta because they're PNGs. It's colored these a darker blue because they're folders. I think WAV files show up as something else. In fact, if I want to go and find a WAV file to show you, and I think there's one in my music folder, one other thing we might want to do is change the current working directory. Right? If we're stuck in this same folder forever, it's not a very useful file system. I would like to say change to the music folder and show myself the files in there. So I'm going to use a new command, the change directory or cd command. I'll type cd and the name of the folder I want to move to, and now it tells me that I'm now in the /music folder. And you'll see something interesting happening here. Originally, we just had, if we go up to our first commands, it told us that it would give us this tilde, which I didn't address at the time. Now we are in tilde/music. That tilde represents your default home directory for you as the user. In this case, tilde is a shortcut for /home/pi, and because it's where a lot of useful sort of documents for an end user live, your documents folder, your downloads folder, your music folder, right? We give it this shortcut value of tilde. So now we're in home/music, which if we want to see the full file path, we can do a pwd. That's /home/pi/music. Yeah, Brooklyn, we're going to get into options in a second here, so before we run through a variety of useful commands, and we'll add some flags to them as well. So we're in the music directory here. We'll do list storage. Oh, there's nothing there. Oh, that's a shame. I know there is a WAV file here somewhere. Maybe it's in my documents or my downloads. So let's go back up a level. How are we going to get there? Well, we can always provide the total path, the global path, the exact path to the place we want to go. So I could say cd/home/pi, and that would take me back to /home/pi where we started. I hit ls, and we get you know, the same thing we had before, right? Let me show you a couple other ways we get back to the same place, right? If I go back into our music folder, I could also do cd tilde, right? Change directory to that home directory, which is again just /home/pi. It can be a nice shortcut to get you places, especially if your username ends up being longer than a couple of characters. We're also, let me show you one more way to get back there. If I am in a directory, the shortcut for the directory, the parent directory of where I currently am, is double dot, right? So if I do cd ... it takes me back sort of up one level in my directory structure, and I get back to, again, /home/pi. In the place you currently are, 2 dots refers to the directory immediately above you. A single dot refers to the folder you are currently in. So I could say cd music, but I could also say /music, should work, right? And because this dot is filling in as the folder that we're currently in, this is basically the same as saying /home/pi/music, right? And it just sort of depends on where you want to go, what you think is fastest. I usually do, if I'm just moving up a level, cd ... right? Get me up one level. Let's go hunting for that wave file that we were looking for. It might be in my documents. We'll say cd, is it document or documents? I'm not actually entirely sure, you know, which it is, although I know it's on the screen there, but bear with me for the sake of example. One nice feature of the terminal emulator that we're using is autocompletion, right? So if I just type doc and hit the tab key, it's going to be picky about capitalization. If I type capital doc and the tab key, it will autocomplete the name of that folder if there's only one that matches, right? So I can cd into my documents, and let's see what's in here. It's just a few things. So I've got an ebash folder, I've got my couple of Python scripts, I've got a text file, and I've got my Python programs folder, which is all well and good. One thing you might want to do, and this is a little bit off my script, but whatever. You're not here for scripted scripted things. We can do some basic text editing, or really, if you're a pro, you're advanced text editing. I am not. I try to minimize this. I like a nice IDE personally. You can edit text and other text-like files, Python files, directly in your terminal, right? Using a variety of programs. Vim and Emacs are probably the most talked about because they're very powerful. They're also really hard, I think, to get your feet wet into, like taking the first bite of the apple. I would propose, if you're just trying this for the first time, using something like Nano. And to use the Nano program to open a file, we just type nano and then the name of the file. And again, we have autocomplete, right? So I could say autocomplete to hello-gist.txt. Micro is a better Nano. Let's look at Micro. I've not used Micro, but let's look at it. So Micro, hello-gist, hit enter. Oh, I don't have Micro installed. Damn. Well, I'll show you Nano then. We open a very basic terminal text editor here that literally just says hello gist. I think this was a file I was using when I was automating turning my sample code into gists, which are GitHub's way of storing code snippets. You'll see down at the bottom there's various sort of text-based shortcuts for how to modify various things. Right out down at the bottom there is their terminology for like what you'd think of as save to file, right? So if we make some changes, hello stream folks, and I want to save that, I'll do Control O. It'll ask me for the file name. If I just hit enter, it will overwrite. I hit Control X, and we hit this right back to the terminal, right? So if you're using the shell to do some basic access and modification, a really simple text editor like Nano, or if it's installed, check out Micro, apparently. Thanks, Brokebuff. Can be really easy things to do. So we can do more than just move around between file structures and access and modify files. We can actually move the files around themselves. We can use things like the move command, MV. I think this hello gist file is related to my Python programs file, which really is where it should live. So I'm going to do move hello gist, and again I'm going to use autocomplete there, right? I don't want to try and remember what all the capitalization was internally. I'll just hit tab and get auto-completed. I'll say move hello gist and then tell it to move it to the file. And actually I might have the syntax wrong here. I guess we'll find out. Give it a place to move it, right? Seems to have completed successfully. It hasn't thrown me an error. And now if I do list storage, we'll see that that file has disappeared. And now if I cd into my Python programs file and I do list storage, we should see our hello-gist.txt is right there, right? So the move command takes a name of a file and a destination to put it in. You can also use move to rename things, because what is renaming other than moving a file to sort of the same location with a different name? So I could say move hello-gist.txt to dot slash, right? The dot refers to the current folder that we're in, right? So in our current folder, move this to hello stream.txt. Hit enter, and now when I do our list storage, we see that hello gist is gone and hello stream has taken its place down here. Yeah? So it's sort of an overloading of the move function, but if you think of, the move function is going to pick up a chunk of binary data and put it in a different place. I can either keep sort of the same textual label on it or not, right? And if we're moving it to the same place with a different label, that's just the same as renaming the thing. That has always made some sense to me. Hopefully it makes some sense to you as well. A few more commands just to blast through here, and I swear we are getting to remote access. I should say, part of the reason I'm focusing on the subset of commands that we're looking at tonight is because I think they are sort of the fundamentals of moving around in the shell in the file system. We won't get into anything super advanced, but hopefully it's enough that when you start to see this code or these shell scripts, these commands pop up in these online tutorials or in like you're experimenting with new software and it says go into the shell and type this, you have the basics of how to get around the system, and the specifics of the commands can be sort of the next layer of understanding on top of that as you explore. So hopefully this is a good foundational level, like what is the shell itself doing? How do we get around it? I'm providing you how traffic laws work, but you can sort of drive to wherever you want, but I'm not going to give you a map to every building. Tortured analogy, but I think it's okay. Just like the move command, we have a copy command, right? CP, and again, it takes a file name and a destination. So I could say copy hello stream.txt to hs.txt, and I guess I think it has, I don't know if it has to be a total path. If I just give it hs.text and ls, yeah, now we've copied our hello stream to hs.text. And let's open that up and just verify that they are the same. We'll say nano hs.text, and there's our text file from before, hello gist, hello stream, and I'll hit Control X to just exit out of that. I feel like I'm kind of flying through these, but none of these commands are terribly complicated as their sort of basic operation. Please do ask questions or stop me. But in sort of like just giving you like the base layer of flour on your cutting board, to use another tortured metaphor, I think this will be a good foundation, and then we'll get on to how you would do this stuff over a network, sort of do it remotely. Also, I should say, and Brokeboth, thank you for being here. I know Kenneth may drop in later tonight as well. If anyone has used these before and has corrections, tips, suggestions, please toss those in the chat as well. Like I say, I'm not an expert. I am a nerd and a maker, and I think this is a useful skill, but I'm not a network professional. So if you know the better ways to do any of this, I'm all ears. What are we making with that flour? I feel like we had a pizza metaphor going back in the fall. Maybe we need more pizza on the thing. Yeah, Nate, they're new headphones. They're incredibly noise canceling, so I sound very strange to myself tonight, but I think I will get away with that. I'll get used to that over time, I should say. Let's see, so we copied a thing. What else should we look at? I see it said looking at his cheat sheet. Let's remove some things, right? This hs.text file isn't really going to do us any good. I can use the rm, the remove command on that file to delete it. So now if I list, that hs.text is gone. You'll see it didn't prompt me to say, hey, are you sure you want to delete this? Are you really, really sure? There are some versions of the rm command, like the infamous rm-rf, which is recursive and force, right? It says just delete everything underneath me here. But for just deleting a file, just sure, you want to delete a file? I'm happy to just wipe it out of existence, right? So rm removes things pretty permanently. Dude, no, I don't believe you get an undo in this case. I might be wrong, but most of the time when you're removing files in a Linux-based file system, they're pretty much gone. I wonder if they default to going into the trash. No, I don't think so. No, this is just like things deleted through the GUI, but rm is rm. Let's see. Brokeboth points out move can be really fast. It doesn't have to move the blocks around just the meta. Yeah. So, like, rather than, as we think of this analogy, especially if we're used to GUIs of, files existing in folders, existing in other folders, existing in like the file cabinet that is our computer, Brokeboth makes a good point, right? They're not literally paper files in a paper folder. They're ones and zeros. All of it is ones and zeros on a hard drive. And so we don't necessarily have to move the you know, a gigabyte of ones and zeros physically from one place to another. We just have to say, hey, this gigabyte of ones and zeros was tagged saying it was in /home/pi, and now it's tagged, now it's in /home/pi/documents, right? So it's not necessarily physically moving something unless you're doing something, as Brookboth says, like moving it to a flash drive or a different hard drive, in which case you really do have to move all those ones and zeros across. What else? That's sort of the basic moving things around command. Brookboth pointed out there's a handful of additional flags you can use to look at details of things. A flag is just a... here, let me come down to the bottom of my terminal here. We've been using all of these commands sort of in their default mode, right? We say ls and it does a default thing. But there are, you know, there'd be other ways we want to look at this data. Maybe we want more information. Maybe we want less. Maybe we only want to view certain types of files. In that case, we might add a flag like -a, -l, and so on. I'll show you in a little bit how you might find that full list of flags and what they do for any command. But ls-a, for example, lists everything in the file, including, in this case, you'll notice it's including the dot and dot, right? This folder and my parent folder are listed because I want to see everything that I could possibly know in relation to this current file. Most of the time when we just do ls, we sort of know they're there in the background. I'm not going to list everything, but if I tell it ls-a, show me everything, show me all, please list everything you possibly have. And there may be other hidden files here too that it would not normally print. If you wanted to find out what those flags are, or find out what more commands are, there are some commands built in to help you learn about commands. In no particular order, one of the simplest ones, and we'll see if it works on our old friend ls, is the what is command. So we type what is and the name of a command, and it gives you like a one-sentence description of what that command does. Lists directory contents. Oh, fair enough. What is rm? Removes files or directories. Great, easy enough. This can be really helpful, especially if you're like digesting a bit of shellcode from a tutorial or the internet, or this this guy on a stream on a Sunday night who is typing way too fast and now you don't remember what everything is. You can just say, what is copy? Copies files and directories. Fair enough. What is xcrypt? I'm messing around with encryption on my hard drive and I don't want to run a command without knowing what it does. What is it? It's a password encryption program. Interesting enough. So a really short description of what what the various commands do. What is, and some of the commands we will ultimately see sometimes will fail on these very basic commands, which are part of the shell environment themselves. In which case you can also get some help on commands with the help command. If we do help ls, ls is not under help. So these various sort of like helper commands that we'll do in a second here, some of them apply to some commands and some apply to others. So it's always worth trying a couple. Let's see. Yes. So Brookboth mentioned that you can also, with a lot of commands, run them with the h flag, and that will bring up a version of the help for that particular command. So you can type, in this case, let's try xcrypt-h, right, which normally won't do anything except, command not found. So I don't have a help file for that, but I might have a manual file by using the man command. And I think xcrypt, it's just we're not going to look at encryption or passwords tonight, but it's just like, it's a command that you might stumble across in a weird corner of the internet and be like, I want to know what this command actually does before I run it. So if I type man and the name of a command, I get the man page, the manual page, the Linux programmer's manual for that particular command. And it will tell you in usually pretty good detail how to use that command and what it does, and sort of a text-based description and a synopsis of what the various flags and options do. So if we scroll down here a little bit, we see the function password to des takes a character string password of arbitrary length and fills a character. It tells us what the command does. Let's look at a command we know a little bit more about. And we'll see down at the bottom of these man pages here, we say press H for help or Q to quit. So I'll hit Q and we'll move back here. Let's do man ls, right? ls list directory contents. And it says how synopsis is like, what do you type in? How do you use it? We say ls option file. List information for the files, the current directory by default, sort entries alphabetically if none of these options nor -sort is specified. Mandatory arguments to long options are mandatory for short options too. So a lot of the time, these options like -a that we saw a moment ago for list all will have a short code and a long code, right? So you could type -a or you could type --all. So a short dash and a one letter usually code, or two dashes and a sort of a textual description, right? So if I quit this for a second, I do ls-all, right? I get the same thing as if I typed ls-a, right? So you sort of get a choice of, you know, whether you want to keep things as short as possible or as long as possible. Personally, I think if you are distributing information, like say run this shell script with these options, it is a nice thing to do for comprehension's sake to spell out all of your options in the long form code. It will take up a lot more space, and of course you don't need to memorize them, right? If you're going to type in like Brokebath says, like ls-lah, right? You just type lah, but you could also say --all. What's our L option down here? Use a long listing format. Okay, so we don't actually have a long spelled out version of this. We just get just -l, and then -h, --human readable. So we could say --all, --human readable, -l, right? And that would be the same exact thing. And if you were to come across that on the interwebs or in a discussion like this, here, I'll show you. Technically, on paper, -lah and ls-all, -human readable -l, right? They do the exact same thing. You actually didn't probably see anything change on the screen here because the output ends up being the same. But -all, -human readable is a little bit more communicative than LA. So if you're typing this up for tutorial's sake and what we'll be looking at tonight, this can be a nice option to have. You may have noticed me do a thing there, which is awfully convenient. I wanted to go back to the previous command, and in most shells, you can bring the previous command or commands up by hitting the up arrow on your keyboard, and it will cycle through your command history back until the point where you opened this terminal, right? Which can be really handy, especially if you make typos, right? If I forget something here and I just say -human readable, it actually didn't throw up on me as much as I thought it would there. That's not throwing up. I wanted it to throw up. -all. There we go. The invalid option, no option J. Oh, I've made an awful typo. I can use the up arrow to bring back my previous command and just sort of make a correction there. So the up arrow and the down arrow can cycle through your command history as you have it. They are specific to this instance of the terminal. So if I closed this terminal window and open a new one, which I can do, right? I don't have previous. Oh, we do. Not every terminal environment gives you persistent access to your command history. This version of Bash does. Well, that's good to know. That's very handy. Thanks, terminal. What people have some thoughts here. Oh, number in parentheses is the section of the man pages. I actually didn't know that. I was like, oh, that's number is always with that particular command. But there you go. Thanks, Brokebath. Run man is a list of the sections. Ooh, let's do that. Yeah, see, this is why I like doing these things. People know things that I don't. Sorry, not run man. Man. Yeah, wow, I can all of the things. All of the various sections. Here we go. Here's our sections. Executable programs or shell commands, system calls provided by the kernel, library calls, special files, file formats, games, miscellaneous system, and kernel routines. Cool. I didn't know that. I learned a thing today. That's great. And it shows you how it's going to display the various bits of text in your terminal here, right? Because the terminal by default isn't going to show you bold, italic, or other formatted text. So say, okay, this is how I'm going to, show these various things to you. If they're formatted in my man page as italic, I'm going to underline them instead, things like that. So that's the man command, and we can run man on any command that we know about pretty much. There occasionally are not man pages for things, and I'll show you a couple of the places you might look for information on them. But for example, the copy command, right, takes some options, takes our source and our destination for sure, or our source and our directory. And for options, we have lots of different things. We could say we use the archive mode, we could copy just the attributes, we could copy the contents of special files when recursive. We could force some copying to happen. We could say if the existing destination file cannot be opened, remove it and try again. We could force an overwrite doing our copying and so on. So as you're looking at commands, the man file is a really easy way to sort of see like what are the options and or what do the options do. We can say man pwd print working directory, and we get some various options here as well. So we don't take any arguments, right? We don't say print working directory and then a file name. That wouldn't quite make sense. But we can say print with the -L option, use the pwd from the operating environment, or avoid symlinks, which are like shortcuts in a GUI metaphor and so on. You can do --help or -h, as Brokeboth points out. A lot of commands you can just say -h and it will bring up, I guess, not copy. Does ls-h have a thing? ls-h is something else, but a lot of commands, like some of the more advanced commands we'll look at in 1 second here, instead of doing man something, you can say the command -h and it will open its own help file. For the commands that don't have a man page, they will often have an info page. And the information is not necessarily the same. So here's, for example, what I did here, info ls, right? We were looking at man ls earlier. Here's the info file. Tends to be a little bit more verbose, right? And formats a little bit differently than the man page. But this can be a way to look, especially things that don't have a man page. This can be a good way of finding out info about them. And I'm not going to go super deep into the functioning of the man pages. Oh, Brooklyn says GNU commands. GNU commands don't like -h. More modern ones do. Oh, that makes sense. So like the primordial commands, which is mostly what I wanted to like look at tonight. ls, copy, move, the sort of like the flour on our cutting board, as we were saying earlier. Cutting board, pizza stone. The cornstarch on our pizza stone, as we were saying, right? Go back to some of the various early days of the GNU shell. Or the origins of the bash system, I guess. And so they are unlikely to accept -h or --help as an option. Good to know. Brooklyn, I may have asked before, what is your background, if you're willing to share? I'm just curious. Anyway, but I'm glad you're here. I'm glad somebody knows these things, because when I get into like, this is the history of GNU and bash, I feel like a youngster. I feel like I'm just new to this scene. And in the scheme of like free software GNU, I totally am. So this is, as I will say about a lot of things, not an expert, just like I'm a maker and a nerd, and I'm hoping this is as useful to you. This little taste is as useful to you as it is to me. Let's look at a couple other useful commands, I find applicable and which we'll use tonight. One of them is ifconfig. ifconfig is a command which can both show you information about your network connections or configure options about them. If you just run ifconfig with no arguments, you get basically the status of all of your extant network connections. And so at this point, I can see that my Raspberry Pi has 2 connections. I have an internet connection of some sort at 192.168.0.115. It's netmask. It's got an IPv6 address associated with it as well. And then I have this local address, this loopback address, which is just going to send any packets that go into it, basically come right back to this computer. So this is, for all intents and purposes, my internet access from the Pi, or my network access, I should say, at the moment. I mean, if I had a Wi-Fi connection enabled, it would be listed here separately. And the name of this connection internally is ETH0, Ethernet Connection 0. I might have an ETH1 or ETH2 if I had multiple network interfaces, if I had Wi-Fi. Although sometimes Wi-Fi shows up as a WLAN name here, but ETH0 is sort of the unique identifier for this connection on my computer. And this is a really easy way, if we have access to a shell, to find the IP address of our device, which will become germane later. So much like all the other commands, we can say man ifconfig and see all the things it can do. It can be used to configure the various network devices, display a short list. Let's actually see what that shortlist format looks like. So the ifconfig-s, and I get, so I get a real short summary of like what's happening on my network interfaces. So I'm receiving quite a bit of data and sending a little bit more data on my Ethernet network, and hardly anything is going over the loopback, which makes sense. I'm not really sending anything there. What else can we do with ifconfig? Man ifconfig. interface can be told to be activated or deactivated using the if command. So, strolling through these man pages can just sort of tell you what a command can do. You can add an IPv6 address to an interface or take it away, create a new IPv6 and IPv4 tunnel through your Ethernet endpoint device, your network interface there, if you really wanted to, if you want to contribute to the deterioration of IPv6 adoption, which I understand is not great. But this is just the ifconfig command, a really easy way to find your IP address on a given device you have access to. What else? There were just 3 more things I wanted to talk about. One is you will often see commands prefaced with sudo or sudo, which is super user do. And what that means is, much like in other operating systems, especially Windows-based ones, you have this idea that the generic user of a computer shouldn't be allowed to just do anything. Especially, excuse me, if you've ever used a work computer, and you've been trying to download something, and the computer says, hey, you have to ask an administrator to download the software for you because we don't trust you. That's because you are not a privileged user on your device that you're using. And in a Linux-based environment, in a Raspberry Pi environment in this case, we, by default, although I don't know what permissions the Pi user has, but you're often operating in a way that you are not a super user, you are a plain old user. If you want to execute a command in a super user-like fashion, you can use super user do, su-do, or sudo, to say, hey, the next command I run it as super user. I don't want to change users, or I don't want to become a super user. I just want to do this one powerful thing. Yes, trust me, I'm allowed to do it. So that's when you see sudo, especially if you're going to be installing new software using the command line, or the terminal rather, you will see a lot of times it'll be prefaced by sudo, because the person who's putting together the instructions can't assume that you're running as a privileged user. So just say, okay, just type sudo in and I'll make sure that we run as a super user. And oftentimes, if you're not a privileged user, you will have to type in a password or a username and password for a privileged user. I think if I, let's see. The next command will normally have to be run as a super user. So let me show you what it is, and we'll find out if we need to use super user or not. Sudo bang bang for running the previous command. Yeah, lots of useful shortcuts in there that I will be honest, I'm not totally familiar with. Bergman says I don't have IPv6 set up on my home network. Yeah. IPv6 on local networks is super overkill to me. Get it for the internet itself, says Thomas, or for massive networks, but otherwise v4 is enough. So, I don't have a high horse here. I have a very low horse, but my thought and tell me how you feel. If we could transition more fully over to IPv6, then NAT is a thing of the past. And the level of kludge that NAT, network address translation, is, which for those, if you haven't heard about it before, we'll talk about in a bit when we get to looking at internet access to your Raspberry Pi that's sitting in your house, which we'll go into just a little bit. If we could get rid of NAT and just all exist in IPv6-based world, a lot of end-to-end communication could be, if not necessarily better, then less kludgy. But I don't see a world where that necessarily happens, because ISPs are not incentivized to remove network address translation, because they'd rather have more presence and more control over the valuable address space that they already have, and more presence in how their data is actually flowing through their data center by just having an endpoint device. Port forwarding, a total pain. There are certainly costs to the transition. I'm not saying it's free. It certainly is not. But that would be the advantage once we're there, I think. Anyway, that's, again, not a high horse. Love to have this conversation with people who know more about it than I. That's just that's the thing I run into. I'm like, oh, this is a thing we have the tools and the technology to solve. Veering back towards sudo for just a second here, one of the commands you will often see it used with is the apt command, or the apt-get command, which is used to install new software. So for example, I just should have thought of some software I could install. I could say apt-get install. I have Thani installed, but let's see if it will Could not open lock file, permission denied. Unable to unquire the dpackage lock. Are you root? It's saying, are you a root user? Are you the most powerful user you can? And apparently I'm not. Myself, and my name here, in this case, my username is Pi. Pi is not a root user. Pi is a basic, regular old, non-privileged user. But if I do sudo apt-get install Thani, that's happy to try. It's like, oh, you're a super user now. Well, forgive me. I will gladly take it a try. Now, it says, now I've already installed the latest version of Thani, right? The Python IDE we've been using for a bunch of the Python nights, so it's not going to try and install it again. But notice the difference between, I can't even see what part of the system you're talking about, bud, to, hey, I'm a super user. It's like, oh, well, then say no more. Thomas says, I am root. So that's the sudo command. All it says is I'm escalating my privileges for the purposes of one command. You can also use the su command, which is the super user command. And after you type in your user password, now you're operating with all your commands in a privileged way. Well, I guess if you enter your password correctly, you do. I hope that's right. Oh, I guess I don't know my own password. But I did change it, and how strange. In any case, the super user command, when you know your own password, apparently, will basically put the shell into a mode where you are operating as a super user for everything. My feeling, and again, not a high horse, a little pony of a horse, is it is often better to just use sudo every single time so that you don't accidentally end up running commands as a super user that you don't need to, right? The sort of safety guard, the guardrail of having to type sudo, which really means, yes, I give me superpowers for this one command, is a good guard against doing something silly like deleting your entire operating system with a misplaced rm command, for example. Let's see, maybe the other Jeff changed it. It's possible. Yeah, how bizarre. I hope that doesn't come back to bite me later when we try and SSH into this thing. Let's see, we talked about sudo, we talked about ifconfig, and we talked about apt-get. That was, honestly, that's the list of commands I wanted to show you, right? So we talked about, in no particular order, just to run through them real fast. pwd prints where we are. ls prints the files and folders in the current working directory. cd changes our directory, and we looked at autocomplete, right? We type the first couple letters and hit tab. Autocompletes to something. We can move files around using the move command, although there's no files on my desktop currently. We can also move up a level with ... a shorthand for the parent folder. We can copy files using the copy command cp. We can remove them with the command rm. We can use sudo to become a super user to do fancy things like install programs. I should say, so apt-get and apt, the installation program, have lots of different options. Install is just one I commonly use. There's apt-get remove, and you can see sudo apt auto remove. It's suggesting here to automatically remove some things I don't need anymore. So apt-get install is not one command. It's the apt command with the install flag. But that's a little sidebar. So when oftentimes you're like, I'm going to play with this piece of software, and it says, okay, run sudo apt-get install these things. Now you know the basics of what that means. ifconfig, which we use to configure network connections or see their status. We looked at what is, the command to show the one line of what a command does. We looked at the man pages, man ifconfig, that show a longer, more verbose description of how to use a command. We looked at the info page, ifconfig, which was sometimes the same or sometimes a different version of explications of the command. Oh, and there's one more thing I wanted to show you, which is the apropos command, which is kind of useful, kind of not, but it is kind of fun. So the apropos command is a command you can use to search the man pages and the names of commands for things you might want to do. So for example, one thing we haven't talked about is how do you find files or folders in your file system through the terminal, right? So I can say apropos find, and it's going to look for that word find in our list of commands. And it's going to come up with a lot of them. And this is the thing that is not good about the apropos command, is that it doesn't give you sort of any curation. It just says, okay, any command that has the word find or in its name or in its description, I'm going to show you here. So there's like 20 different commands here. Everything from fc pattern find iter, set the iterator to point to the object in the pattern, to a command just called find, which seems like a useful thing right there, find file system by label or UID, and so on. So this can be a place to start looking for commands that are in your system already with a purpose, but sometimes it's easier just to go to Google and say, what's the preferred bash command for finding a file in a system? And there will be opinions. There's usually not one right answer, but in that case you would find find and grep and a few other things to search for files in a system. Oh, Brooklyn's ifconfig is deprecated in favor of the IP commands. I actually didn't know that. I've always just used ifconfig. Let's see. Well, this is, again, another good time to learn. What are our IP options? If I just run IP, let's see. What am I? Here, this will be great. I don't know this command, but let's see if we can learn about it using the man page. Let's see. IP version shows the version of the IP utility. -H is output statistics with human readable values followed by suffix. That sounds good. Can I just do IP-H? No, I need more options. I need an object to operate on. So if I say IP-H ETH0, oops, if I type it correctly. No, that's not the right syntax either. Man IP is how you, IPA, thank you. IP-A, IPA. Very good. So yeah, so here's our same interfaces. We have the local loopback, we have ETH0, which is my wired connection. And it's actually interesting, this one is showing, and I think the ifconfig-show-all command, or the -all, shows me inactive network interfaces. Because I don't have a connection on this, it didn't show me in the ifconfig, but I do have, of course, Wi-Fi built in. That's very cool. I will have to explore this more. Details. So I say IPA-DA. Yeah, now I get all the various details about my network interfaces. Number of queues, routing preferences, valid LFT forever, preferred. Fun. Neat. Cool. Thanks, Brokebuff. Well, as always, I'm going to pause for a second and ask for questions, which really just means I need to wet my whistle. I guess I should say, for those who are curious out there, maybe nobody is, but it's fun. Tonight I am drinking a Cosmic IPA, the Space Camper from Boulevard Brewing Company in Kansas City, Missouri. A very tasty, very juicy beer. If you're drinking something interesting out there tonight, and again, no pressure to, I know drinking is not everybody's thing. If you're not, I encourage you to hydrate. But I like nice beer on these fun evenings when we're just hanging out together, so cheers. I think it was last week or maybe last night I was having that like very mild wheat beer, and this is like, it's like eating a guava fruit in liquid form. It's very good, but it's very flavorful. Ooh, Chris is having an Energy City PB&J. Ooh, that sounds good. ifconfig still works on BSD systems. I gotcha. Yeah, so they just wrote a whole new command rather than trying to like break things in the past. That's nice of them. I think that's probably the preferred method of operating. Yeah. So, okay, so we've talked about the shell. We talked to death about the shell. No, we haven't. We talked a little about the shell because, you know, this is obviously a relatively powerful way for us to interact with the system. There's all kinds of ways we could do with it, and the output at the end of the day is just text, which is lightweight and easy to move over a network, which makes it a really sort of, oops, sorry, that's a very, sort of strong, stereotypically masculine sound there as I knock my iPad with my cheat sheet on it off the table. I have no regrets. So let's look at a way that we can basically access a shell on our Raspberry Pi remotely to gain access to the computer. Now, setting this up on the Pi is relatively straightforward. By default, Secure Shell Access, SSH, which is the set of protocols that allow us to open a shell, open a terminal on a remote computer, SSH access to the Pi is disabled by default, but there are a couple of ways to enable it. One is if you have, if you're setting up your Pi on your workbench before you go out and staple it to the shed, right, you can do this through the GUI interface, right? So I'm gonna close my terminal here. If I come up to the Pi menu, come down to Preferences, come to Raspberry Pi Configuration, and then in the Interfaces tab, we have a whole variety of sort of connections and various things we can enable or disable. SSH starts out as disabled. You'll just click Enable enable. You'll hit OK, and usually it will ask you to reboot at this point to enable it. You'll see I've also enabled our VNC server here, which we will make use of later. So I enabled these in advance. This is sort of the one I prepared in the oven earlier, because when you do usually have to reboot to enable these, and as we've discovered in the past, the video capture of the Pi is sometimes a little bit temperamental when things reboot. So for our purposes, let's just say that we just did that. We enabled it, we rebooted, and here we are. So now that we've enabled SSH, how do we get into it? Actually, before we do that, let me show you another way you can enable SSH on a Raspberry Pi. Let's say you, just for the sake of argument, you don't want to have to like set up a whole monitor and keyboard and mouse on your workbench only to enable SSH and then go staple it to the shed outside. Wouldn't it be great if there was a way that we could just say, hey, operating system, please just have SSH enabled, excuse me, by default, before I sort of put your SD card into the Raspberry Pi and go staple it to the shed? It turns out there is. What you want to do, bring over to the Windows computer over here and try to remember which mouse is which. Let's see here. There we go. There's a nice mouse. We will... so let's say we've used our... And this is going way back to like the... Oops. Closed every window on the computer, which is not what I meant to do. Because now I can't see what anyone's saying or what my face is doing. There we go. All right, that's better. So what I have done is use our old friend, the Raspberry Pi Imager software, which we looked at way back, I think, in the very first Raspberry Pi chat that we did, which is a really easy way to just like put the Raspberry Pi OS on an SD card attached to your computer. I've actually already done this because it takes a little while. It downloads the image fresh, it puts on an SD card of your choice, and then verifies it. It takes, I don't know, 8 to 10 minutes on my network. So I've already done that, and I've put the SD card back into the computer. You'll see it showing up, if you can't see it, I'll tell you, it's showing up as this boot drive here, which is one of the partitions of this, of the SD card that's going to allow the Pi to sort of boot its operating system. The way we can enable SSH by default in our system is to put a file with no contents and no extension in this boot drive's root folder called SSH. So on Windows, very simple, and Mac is very much the same. I'm going to open, for example, my notepad. So I've got a new file here. I'm not going to put any text in it. Let me shrink this down a little bit here. Oh, that's the chat. I guess the chat is just off screen right, as it were. Bring this over here. Now, if nothing typed in, I'll hit File Save. I will navigate to our boot drive. Looks like we're already there. And I will say save this as an L file, and I will do in quotes, so it doesn't default to any file name. I'll do quote SSH and hit save. I'll hit save. I'll hit save. There we go. So it saved that file. I can close this up, and now if I refresh our view here, we should see an empty file called SSH just sitting in the root directory here. When the Raspberry Pi boots up, it will basically the operating system will see that that file is present. It will enable SSH. And then it will delete that file for us, right? So this is a way that we can sort of install the Raspberry Pi operating system fresh and install it somewhere out in the field to start with. Maybe no monitor is ever attached to it. And it will already have SSH enabled so that we can get in and command it. Broke makes a very good, we'll talk a little bit about authentication. Yeah, if you're going to be putting this on the internet, and like we said, we'll sort of talk about that toward the end of the night, then there's all kinds of things that you want to do to secure your device. Terminal and touch commands work too. Windows, so some Windows computers have like the touch safety, but not most of them. So I have never set it up personally. So I don't really know that much about it, but it's a fair point, Broke Both. Yeah, you want to be careful about what you expose yourself to on the web. So what I will do to sort of prove the efficacy of this setup method here, right? So we've set up our SSH file in the root directory of our boot folder here. I'm going to pop this into our second Raspberry Pi here. So I'm just going to eject that SD card. I'm going to pull that card out of the little portable little USB card reader I have here. We'll pop it into our second Raspberry Pi. Now, there's always a danger in doing these things live that they won't work. But you know, when we did this earlier in the day, it did work. So hopefully everything will turn out quite well. All right, that's plugged in, case is there, and we'll plug in our power supply. And it will take a minute or so to boot, so we'll have to be a little bit patient here. But while we do, we can look at how we might SSH into our existing Raspberry Pi, let's say. All right, so that's plugged in. See the power light glowing there, so that'll take a couple minutes to boot up. So in the meantime, let's get ourselves a shell on our existing, you're over here, existing Raspberry Pi. There are a wide variety of programs you can use to create a secure shell connection. My sort of preferred one, it's an old one, but a good one is the PuTTY program, which is available for, I think, Windows, Mac, and Linux. It will kind of do a little bit of everything. And you'll see when we start it up here, it asks for a very basic set of parameters to create a connection. It says, what is your host name or IP address? What port? And port numbers are related to the protocol that you're communicating in. So typically, if you select a different protocol down here, rlogin or telnet or raw, whatever, it will change this port number for you. For almost all SSH connections, you're looking for port 22. So you can just leave it at that. And in this box here, we'll put in to start with, the IP address that we gleaned earlier from our ifconfig command, right? So come back to our terminal for a second. I'll say ifconfig. And my IP address is 192.168.0.115. Now you're probably already asking, what if I don't know the device's IP? I got you covered. Hang on a sec. So if I come over here to PuTTY, and I know the interface is a little bit small here, so I'll just narrate as we go. I type in my IP address, 192.168.0.115, and hit open. It says log in as, so what user do you want to log in as? By default, the default user on the Raspberry Pi is the user Pi. We can see when we open a terminal, right, it says that we are user Pi on the device called rpi. Now on your device, your default name is probably Raspberry Pi. You can change this in the Raspberry Pi configuration menu where we were making things earlier. You'll see I changed my host name to rpi, and there's a good reason for that too, and we'll see that in a little bit. But I'm just going to log in as this same Pi user over on my other machine. So I'll log in as Pi, and hopefully I know what the password is, and I do. And we'll see it pops up with a little bit of a response from the machine itself. It says Wi-Fi is currently blocked. Use Ras Pi config to set the country before use. GNU Linux comes with no warranty. Totally fair. But now, this shell that I'm using on my, to be clear, on my PC, on a laptop I have that's just underneath this camera here, that you're looking at the screen of, this is the same shell, the same terminal interface as was provided on the actual Pi itself. So I can say print working directory, I can do ls to show the files. It looks like I made the font size so big I'm bleeding off the screen here. Hang on, let me right click on the heading here, and I'll change the settings a little bit to just make this a little bit smaller. Make that 18-point font. Okay, apply. There, that's a little bit better. You know, I can do basically all of the same things that I could previously do. I can run ifconfig or the IP suite of commands that Broke turned me on to just now, which is super cool. So basically, we now have anything that the terminal can do: move files around, edit files, run files. Oh, one thing we didn't mention that the terminal can do is run programs, right? Which we saw a little bit with apt and apt-get is kind of like running a program to install a thing. But we can run programs in any programming language, like the Python programs we've been writing. So let's get to some of our Python programs and run them. So let's see, where are we? We are going to want to change directory into documents, and we'll do autocomplete. What's in here? We'll cd into Python programs and see what's there. Let's see, what might be a good program? Let us look at the contents of the list demo program. I don't remember what that does. We'll nano listdemo.py, and we'll say, so we have a list. Wow, this is a throwback, right? Got Palmer, Chris W, and Jeff Glass. This is like from very early Python class days, right? We did some things to it. We did some things. All right, fair enough. So we'll close that out. That seems like a good thing to run, right? And I can run that program by typing Python listdemo.py, and it will run in our terminal just like it runs in our IDE, right? It created a list. It's asking me for input. I will say carrot cake, right? And then it prints up, it completes the rest of the program, sending its standard output back to the terminal, right? And I guess it was printing that list and then printing what I gave it or something like that. So this could be a Python script that does something interactive. It could run in the background, taking, again, like temperature readings from your shed or network readings and sending them to the internet, or serving as a mail server, or whatever your programming language does. Easy to execute from the terminal here. So now I basically have remote control of anything I can do through the terminal. Just, this Pi just has to be on my local network. It could be here, it could be outside connected via Wi-Fi, it could be underneath my TV acting as a media center, or what have you. Yeah, that's the most straightforward. After 45 minutes of rambling about what the shell is in the terminal and why it's cool, there's a really pretty straightforward way of accessing that shell and that terminal remotely. And that is to use a program like Putty, P-U-T-T-Y, as your secure shell program. But, I hear you asking, you had to know the IP address of that Raspberry Pi to be able to secure shell into it. Or to get a secure shell connection. What if I just set this Pi up, enabled SSH by doing that file thing you were talking about, but then I just want to like plug it into a power supply or maybe a solar panel and go stick it somewhere it has a network connection, but somewhere that I'm not going to plug it into a monitor and run ifconfig in advance. Like, how do I know the IP address? How can I get that information if I don't set it up with a monitor beforehand? There's a solution. I'm going to pretend that's the question you asked me so that I could pause and answer it. I feel like I'm just blazing tonight, but I'm just excited, because this is cool stuff. So, tell me to slow down, tell me to say things again, ask questions if you got them. Always happy to. And, as always, thank you, Brooklyn, for, telling me these things, because, I'm definitely still learning, too. We were talking about what if you don't know the IP address of your Raspberry Pi or your remote device, or you just plugged it in for the first time, and so it's gotten some IP address from your home router, your business router, whatever. It's got DHCP enabled. How do you know what that address is? There's a couple of ways to solve this. Let me come back over to the PC here, and I will just close. Actually, I'm going to close it properly. So type exit, and that will close my terminal session. Let's reopen Putty. And actually, before we get too far, I'm just going to permanently change that text size to be just that slightly smaller size that was so handy. We'll save that as my default settings. So, previously when I made this connection into this box here labeled host name or IP address, I typed in the IP address of the Pi that we got from the ifconfig command. There's another option though. If I knew what its host name was on the local network, I could connect directly to that. And thankfully, Raspberry Pi OS by default announces itself on the network as its hostname.local. So in our case, because I set my host name to rpi, right, I should be able to connect to rpi.local, and that will give me the same exact connection as if I typed in its IP address directly. So let's see if I'm lying. I'll type rpi.local and open. And it comes up with a security warning. It's saying this server's host key is not cached. There's no guarantee that the server is the computer you think it is. If you trust this host, hit yes to add the key to the cache. If you want to carry on connecting just once without adding the key, hit no. If you do not trust this host, hit cancel. Well, I trust this host, but I wanted to pop me up this warning every time, so I'll hit no. And then every time I try and connect to this, it'll prompt me and say, hey, you typed in like a host name, and that's a little scary. I don't recognize this computer. You sure? I'm pretty sure. And just like before, I'll type in my, that's the wrong username. So I actually have to close that terminal setting and try again. So rpi.local. This host is not guaranteed. Yes, thank you. Login is the username Pi. Type in my password, and once again we have our secure shell here that has all of our various bits of access to it, right? So the Raspberry Pi by default, when you first install the operating system, will have the host name be Raspberry Pi, RASPBERRYPI, all lowercase, right? So if you just install the basic Raspberry Pi OS and plug it into a network and some power, within a couple minutes, it will start announcing itself on the network as Raspberry Pi.local. Then you can SSH into it, and from there, if you want to, you can run commands to get the IP address and so on. But that's the easiest way nowadays for a modern install to find this random Raspberry Pi that you just plugged in somewhere. This was not always the case, and this is not generally true for Linux systems, but this is because this is a common issue people were having. It's like, okay, well, I plugged this thing in, it doesn't have a monitor on it. How do I know what its IP address is? Do I go into my router and like look for new devices? That was a suggestion for a while. Or use something like Nmap, a network mapping software, to like find weird network things going on, and that's probably the Raspberry Pi. So nowadays, the Avani system, by default, just says, hey, I'm just going to announce myself as the username.local, and you can find it that way. That, by the way, is why my host name here is RPi and not Raspberry Pi, because I knew at some point tonight we'd be plugging in a second brand new Raspberry Pi, and that one is going to default to raspberrypi.local. So let's see if we can SSH into this new guy. Hopefully this worked. Come back over to our Windows machine. Exit this session and launch a new PuTTY session. And in theory, I should be able to say raspberrypi.local, open session. It says, provincial security degrees? No, that's fine. And in this case, I'm going to be the default user Pi, and the default password is raspberry. And it even will tell you, SSH is enabled and the default password for the Pi has not been changed. This is a security risk. Please log in as Pi and type password to set a new password. Excellent advice. But now I am logged in to this Raspberry Pi. I've never had a monitor hooked up to it. I don't have a mouse and keyboard, but I have control over it through the terminal, through this secure shell that I have on my computer here. So I can see what our files are. I can use our various commands that we talked about earlier. Let's go into what's in the bookshelf. Ooh, it's thinking about it. Nate asked a really good question, which is how would this work when you want to use a wireless connection? Do you have to set up the wireless network before trying to connect remotely? So you would, and there is a provision, much like dropping the SSH file into the... here, Broke has the answer. You set the WLAN login on the SD card. Yeah, so there is a method that's basically modifying the files on that SD card, much like we just dropped in that SSH file. There's another configuration file you can modify. I think it's in /etc/conf or something. You basically give it your Wi-Fi SSID and password, and then when it boots up, it will have that and will join the wireless network for you. I don't know exactly where that is off the top of my head, but a quick Google-roo would probably figure that out. But that's the gist of it. Yeah, it's you basically when the SD card is still attached to your other computer for burning it, you put the information onto the SD card, and then your operating system on your Pi just has it. Good question, a good use case question. Let's see. Look at my cheat sheet here. Let's see. Yes, you can also. When you change a little thing, once you change your host name, whether you're doing that through the GUI, going into preferences and Raspberry Pi configuration, or you're doing it through the shell, which you can certainly do, that the information of what your host name is just a file in the system, and it lives in a place called /etc. What is it called? What's the file name here? There should be a file in here just called hostname. If I edit that, yeah, so I can see, so this file /etc/hostname is just a singular file that holds my current hostname. If you change your hostname here or in the GUI, the service that is automatically propagating this, Raspberry Pi.local or rpi.local, your MDNS, your local DNS, setting will automatically be updated. So if you change your host name here, those changes will go out over the network automatically. So if you were, if you were plugging in a new Pi and saying, okay, well, I'm gonna have like 5 of these, I'll plug in this one, I'll make that, Garage, I'll change the host name to Garage Pi. I'll plug in the second one, I'll change the host name to Kitchen Pi or what have you. It can present issues if you turn on multiple Raspberry Pis at once, right? Because if they're both advertising themselves with that same default MDNS setting, things can go screwy. Oh, it's Kenneth. Now I gotta start being accurate. Or not. Maybe I'll be less accurate, and that'll give Kenneth some good things to be fun. I did offer, I was like, Kenneth, we're talking a little bit about SSH and networking tonight if you want to come, show off your expertise or heckle, or both. But here we are. Those for less accurate. Thanks. Yeah, that's probably the way things are going. So you're in luck. Let's see here. So I think that's basically all we wanted to say about SSH here this evening, at least for now. But what if you want to do something like here we talked about, I didn't even update the to-do list there. We talked about the .local addresses. Let's talk about VNC. Sometimes it can be really useful to have in a remote location this full graphical user interface like we have sitting at a monitor and a desktop here. There are a couple of really easy steps to get that working, especially in the most recent Raspberry Pi OS. If we go into our Pi menu, and again, there is a way to set this up through the terminal as well, but I'll show you in the GUI first. I'll go to the Pi menu, Preferences, Configuration, and interfaces here. I said earlier we enabled this VNC setting. That will automatically launch the VNC Server software. You can see it comes up with its own little icon in the upper right here. This is VNC Connect by Real VNC. It's a product that has sort of helped supplied the Raspberry Pi ecosystem because they want to sell more of their products to non-Raspberry Pi people, but that's fine. It's free software. It works pretty well. Free as in beer. I don't think it's necessarily free as in speech, but here we go. And it's for non-commercial use only. If you're using this for a business, you have to pay the money, they say. So once that is running, we can use some VNC client software to connect to that desktop. So over on our PC here, let's close this session. I've already downloaded, and there is a link in the description to get this software, the VNC Viewer software. Once I open this up, I can either, just like before, type in the IP address of the device, or I can type in the MDNS location, the hostname location. So let's see here. I can type in, for example, rpi.local, which is the Pi we've been working on. And it's going to ask me for a username and password, just like before. Oops. Oh. Username is Pi. Hopefully I just mistyped my password. There we go. So now, there's a little inception there. Now I have a view on my, so the big image here, right there on the screen, that's the PC. The little image above me is the Pi itself, right? So now I have a version of this desktop controlled from my PC, right? So if if this Pi was stuck in a place where I couldn't get to it, but I really wanted to, for some reason, use the graphical user interface. Maybe I had a program that was local to the computer and was making really nice graphs, or was easiest to, maybe have some vendor software that's really only useful to be configured through the graphical user interface. Now I can use this VNC Viewer software, which again, available for PC and Linux and Mac, to sort of get a remote graphical user interface for this. I wouldn't necessarily do anything that's highly graphical over this, like playing a video file on the Pi is not going to look super great on the remote computer, but it's good enough to interact with, right? I could go in to my preferences, and to be clear, I'm moving my PC's mouse, and it's causing the mouse to move on the Raspberry Pi screen over here. Like, if I had to make some configuration change and change the display, the interfaces, again, all of this is stuff you can do through the terminal. But sometimes it's just easier to I know where it is in the GUI. I'll just get the GUI up remotely and make the changes there. That's totally fine. Watching YouTube over VNC. Should we see how bad it looks? I mean, the YouTube on this device in general is not going to look super great, but I can do this all over the VNC connection. Go to youtube.com. Ooh, it's chug-a-luggin'. My Pi 4 only has 2 gigabytes of RAM, so YouTube in the best case is not going to be great. But here we are. As it kind of says, never depend on MDNS, always create regular DNS headers for things. Also totally valid, right? This is sort of like an easy way that the Pi, you plug it in and you can get to it somehow. And once you have a secure shell or a remote session, right, you can kind of do whatever you want from there for sure. I mean, Kenneth, I don't know that I would encourage you to do whatever you want. Oh, let's see. What does it think I want? Oh, we could watch my stream. That seems like a bad idea. We could watch my stream over the stream over VNC. Let's see how well that goes. It's going to be a disaster. Make sure I'm going to make sure the sound capture is turned off, or this is going to be a absolute nightmare. Currently, it's not even loading, which maybe is a blessing. Ooh, yeah, we're chug-a-lugging a bit here, I think is the technical term. Oh, it's thinking about it. This is all really to make a very silly side point, which is that, like, this is not what a VNC session is for, but here we are. No, I don't want to try. Watch for smoke on the pie. It is getting a little toasty. Like, that's why this heatsink is here. It's just to prevent this. I'm gonna close this experiment before anything sad happens. But you might be able to tell even here, just like the frame rate difference between what it's capturing directly on the video of the pie. Oh god, there's 3 chats. There's all the chats, and like the sort of lower frame rate that's happening in the PC side of things. Yeah, this experiment is done. I think I've proved my point. Close. But yes, so launching VNC Server on your Pi and connecting to it with VNC client software is a really easy way to get a remote GUI going. If you don't have access to a GUI to initialize the VNC server, that is also something you can do from the terminal. So if let's say you're in a situation where you have a brand new Pi, you plug it in out by the shed, you get it on your network, and let's see, I guess I would need to disable the VNC server to make this work, and I think that may screw with my video settings, but just to show you what that command is, if you just run VNC server, I'll just pull up the man page for it, VNC server, no man page, let's say VNC server -h, there we go, and it shows me like how the VNC server will run. I guess I can probably launch a second one, VNC server, and we'll say, new desktop is rpi-1. So I have a new desktop that's being served by the VNC server. It's going to be index 1. Because you can have multiple servers running at the same time, so multiple terminals could be accessing different desktops at the same time. But I'll kill that for now. I'll say VNC server-kill1. Oops, that's the wrong syntax. Kill:1. Kill:1? There we go. So now I should have killed that particular VNC server that we started from the terminal. So you could plonk your Pi somewhere out in network range, but not connected to your monitor, mouse, what have you. Find it on your network using the MDNS access, right? To use that Raspberry Pi.local. SSH into it, start VNC server if it's not started by default, and it probably won't be, and use that to get a GUI. And if that's the way you're most comfortable, like getting to the system and accessing it, totally valid. If you can do everything in the shell, so much the better. But now you have sort of a way of configuring this device without having to sort of have access to visuals on it. VNC server can also be really useful in a situation like, to be honest, I encounter a fair amount at the museum, although not with Raspberry Pis yet, which is, my device is a computer, it has a mouse, it has a keyboard, it has a display on it, except all those things are stuffed inside of a wall in an exhibit in a museum somewhere, right? I might have a computer and a giant monitor tacked to the wall, and there is a mouse and keyboard somewhere plugged into the back of it, but I can't have the keyboard and mouse where I can see the TV, and depending on what these walls are made of, wireless keyboards can be a little sketchy. But if they're on the network, or you can run a network cable around, you just VNC into them, and now you have a sort of a remote control display that's good enough for most purposes, like I need to restart this program, I need to see if this file is present, I need to check some system settings, right? A totally easy way to have remote access. So that's the gist of VNC server. It's really, really simple. You enable it, you log into it, again, with IP address or with your local, your MDNS settings. I guess one of the things I was going to try is, can I secure shell into my my new device here? Is my phone ringing? I thought I couldn't tell if my phone was ringing or if it was my headphones here. But I'll tell you, these headphones are so crazy noise canceling, even without the noise canceling enabled. I couldn't tell if it was the tunes or the Biz phone. Freaking me out here. Let's see if we can SSH into the new Pi that we just plugged in. Can't remember if we did this already. We might have. I made it to January 24th, and I'm losing my mind. Wow, it's really struggle bus in there. Oh, something is hung in the boot sequence of this secondary Pi, and I can tell because I think it has at least. Oh, maybe the process light has just died. Something strange is happening here. Let's see. Let's go into our command prompt. Raspberry Pi .local. Oh yeah, I'm seeing it on IPv6. Interestingly enough. But for some reason, can I SSH into it? Oh, you know what? I should SSH into it because it probably doesn't have VNC Server running. So this would be a good example, right? So this is our Raspberry Pi out in the barn, right, on my long wireless network that I've just plugged in for the very first time. So now we'll SSH into it. We'll connect through PuTTY to Raspberry Pi .local, and it'll say, no, it's a security risk, but that's fine. My default username is Pi. My default password is Raspberry, and it will tell me that's very insecure, and I agree. And now I'm going to launch VNC Server with the VNC Server command, and it's going to generate for me a private key, which is awfully nice. Because I guess I have not run a VNC Server on this particular Pi before. And now that VNC Server is running, I should be able to connect to it using my VNC software, hopefully. If I can't, we'll try connecting directly via IP address. Let's see, ifconfig. This is 192.168.0.118. How strange. This did work earlier. I did warn you that doing these things live, we might run into some shenanigans. Is it enabled? Yeah, that's what running that VNC server command did, Chris, would just boot up the real VNC server to punt it over the network there. In theory. Timed out, huh? Let's see. We won't spend too long on this, but it'd be a little bit of a shame if it doesn't just work. I did this literally an hour and a half ago and it did, but that's streaming for you. That's trying stuff live. Now something is screwy. Something is screwy there. In theory, this should work. That's good streaming for you. Hey kids, do this thing. It should work. It didn't for me, but in theory it should for you. I don't know what's happening here, but oh well. I'll take that as a loss. Kenneth asks, is it unhappy because it doesn't have a monitor plugged in to emulate? It's possible. How could we test that? I wish I had another HDMI monitor I could use. I do, that would be kludgy. I do have an HDMI display. Maybe the GUI can't init without knowing what resolution to start at. Maybe. I wonder if there is an option in the VNC server that would allow me to like force it to be a resolution. So let's kill that display. VNC server -kill VNC server -h. So can load XORed options from file. Run VNC server on display. Yeah, so I may not have any displays for it to think to run. Let's list some options. VNC server -list. Wow, this could take a little bit of a time to sort through. Probably not the most thrilling stream quality anyone's ever seen. Those are some options. You're not wrong. Lots of lux. I believe there is a way to do this, because I have done it before. And I think I did it just a little bit ago. I'm trying to remember if there was if the hardware was configured differently somehow. VNC server -kill. I guess we killed it already. VNC server kill 1. Yeah. All right, it's gone. Well, that's all right. We'll figure it out, and maybe we'll bring it back in a future Raspberry Pi class, because that seems like a useful thing to be able to do, if it is possible. So we've talked about Secure Shell. We talked about finding your Raspberry Pi's IP address. We talked a lot about the shell and the terminal, at least the fundamentals thereof. We looked at VNC Server. We got it working for a Pi that is hooked up to the display. We did not get it working for a Pi not hooked up to the display. Thoughts for future. Let me talk just a little bit about how to, and this is, as both mentioned earlier, this is not necessarily a good idea, but something you may wish to do, or have the desire to do, is have a Raspberry Pi on your home network and have access to it from a different place on the internet, right? The situation that I've run into, and I did not implement this because I didn't figure out that I needed to do this. Nate says Raspberry config. Ooh, let me finish my sentence, then we're gonna get down this rabbit hole together. Because now I want to solve it. The situation I ran into with wanting access to my Raspberry Pi from, somewhere that's not inside these four walls was using the Octoprint setup on an Octopi board. Basically turns your Raspberry Pi into a print server for your 3D printer. So you hook up your Raspberry Pi via a USB or serial cable to your 3D printer. You send it print commands and files over the network, and it prints, and it can do nice things like you hook your webcam to it up as well, and you automatically do a time lapse or show you the status or take a picture every so often or what have you, real-time temperature monitoring, error monitoring, that kind of thing. That's a really useful thing for me to have here in the workshop, but it'd also be kind of nice if I could access that, from my phone when I'm, out and about and be like, hey, is my printer on fire? Is everything okay? There is a real danger in exposing your device itself, your computer, your Pi, or whatever, to the internet. That's why when you log into SSH with the default passwords, it throws up on you immediately. It says, hey, if you put me on the internet with just these default passwords, you're gonna get owned, and you will. So I'm not going to go super in depth into the process of. Thanks, Kev. Yeah, I do leave occasionally. I'm going back to work on a week from tomorrow, so there you go. I'm not going to go super in-depth into the process of hardening your Raspberry Pi so that it is a safe to expose on the internet. And what I mean by expose on the internet, we'll talk about in a second here. Just because I'm not enough of an expert in Linux or Raspberry Pi to tell you all of those steps, we will sort of briefly go through the guide that the Raspberry Pi Foundation puts out, but what I would encourage you to do is follow that entire guide, and then probably follow the top. This is a risky statement. Follow some nice guides out there that's been written in the past couple years. Look through Stack Overflow. Try and make yourself a little bit of an expert on this before you sort of just throw your Pi out onto the internet. But I will go through the basic steps and then talk about the couple other things you would need to do. So this is an option where your Raspberry Pi is acting as a local print server or file server or media server, and you want to have access to it directly from outside of your home. You want it to be available on the internet rather than just sort of having it initiate all of the various connections that it might want to make. So the first step would be securing a Raspberry Pi. So we'll go through this article just very briefly. It's, like I say, it's linked in the description. I would encourage you to follow it in depth as much as you can. This is in the Raspberry Pi Foundation. It's called Securing Your Raspberry Pi. The first thing I suggest is change your default password. A really simple thing, right? It should not be Pi with the password Raspberry. Change it to something much more secure. Use a password manager or a key or something if you have it, just to make it a little bit harder for someone to just SSH into your box and have access to all the things on your computer. Change your username so you're not the default Pi username, and there's a good step, and it gives you the various steps. See here, this is the kind of thing I was thinking about talking about, like fundamentals of the shell, right? So now we see this shell command. It says sudo add user Alice, right? And so we did not look at the add user command. We can probably guess what it does, and we know what sudo does now, right? We're going to run this command as an administrator. It's going to add a new user. So hopefully you start to be able to untangle what these various terminal commands do now that we have some sort of basics of the shell underneath us. Make sudo require a password, right? When I was typing in sudo earlier to become a super user for the sake of a command, it was not prompting me for a password, but it's good practice for it to require to, so that someone can't just SSH into your machine and have root privileges and do whatever they want, and it shows you the terminal commands to do that. Apply the latest security fixes to SSH and keep your system fully updated. Kenneth says, and this is why I wanted Kenneth here, because Kenneth actually has things exposed to the internet. He says, I regularly see people try to log in using Pi Raspberry on all of my public servers on a daily basis. Yeah, this stuff is so common. It's like admin to admin, right? It's like if you're any kind of the laziest script kiddie on the internet, right? You would just say, well, man, maybe they didn't change anything and I can log into somebody else's Pi and cause havoc. Or maybe I can get into their server and I don't know what I'll do, right? But just change it. It walks you through very simply just here. Various ways you can improve your SSH security, using keys. Broke both mentioned this earlier. Rather than logging in with a plain text password, you can generate a public-private key pair and use that as your login method, and that is quite a bit more secure. That there is basically you would have your remote device, your Raspberry Pi, generate this private key pair. You would import these keys into PuTTY or your SSH client of choice. And then each time, rather than inputting a password, a plain text password that you have to remember like a human with your hands, you can use this cryptographic key to prove that you are who you say you are. And it just walks you through how to do that. There are various firewalls they suggest you install. I don't know that that UFW is necessarily the best one for this case, but it's the one they recommend. You can install a firewall to block malicious connections, and how you might do that. And fail to ban. So fail to ban is basically a service that sits on top of your SSH connection and says if there are too many failed logins from a given, usually it's an IP address, then either, say, okay, I won't accept any connections from that IP address for a minute, 5 minutes, 10 minutes, or maybe I permanently ban them, right? They can't get in at all. It's an easy way of blocking someone who's like, just, okay, hey, there's a Raspberry Pi there. I'm a malicious hacker. I'm going to try and log in. Okay, is it Pi Raspberry? Is it Raspberry Pi? Is it Pi Raspberry? Oh, I've tried 3 times, and that's too many. I'm permanently blocked. I might as well move on. Or even I'm blocked for 5 minutes. That program is just going to move on across the internet. You're not an easy target, so you're a hard target. So that's another action you could take. There's further readings you could do on all of this, but those are sort of the basic steps that at least the Pi Foundation recommends you do for like the basics of securing your Raspberry Pi. Now, I wouldn't necessarily use this. I wouldn't necessarily use a Raspberry Pi to store my bank details and expose it to the internet, right? Like I wouldn't necessarily put my automatic baby rocker that I secured with my own meager computer abilities on the internet and just having followed one user guide that said it was safe. But for something that was something that is essentially doing, interesting hobbyist things, being a temperature sensor or a weather sensor, maybe 3D printer control, although there is a hot thing in that, and that's a little sketchy. The OctoPi program that does a nice distributed bundle of Octoprint says hey, be really careful when you put this on the internet because, you're leaving a 80-watt hot plate exposed to the interwebs, and that's maybe not the best idea unless you really know what you're doing. Part of the reason that I sort of backed away from that product. Kenneth endorses fail to ban. Yeah, it's not a terribly complicated thing to configure, is my experience with it, which is very limited. I'm sure Kenneth knows more, but it's a really simple way of saying hey, if somebody tries to log in too many times, just block them, right? Or suspend them for a few minutes, right? A real easy way to sort of add some basic security. So that would be step one of first you harden your Pi, you make it internet safe. Internet safe being kind of an oxymoron, I suppose. The next challenge in getting your Pi accessible to the internet is something we went in a little bit of a rabbit hole about earlier. Just a little bit. And I said I wasn't getting on my high horse, and I'm still not. But if you are operating on a home network, which I am assuming most of the time most of you are, your devices are sitting behind NAT, behind network address translation. And I said for those who had not seen it before, the gist of network address translation is, I'm going to make some assumptions about the motivation behind it, but because of the limited number of IPv4 addresses available and the limited number that ISPs have, rather than every single network device in the world having its own globally unique routable IP address, instead we have our local networks with local IP addresses like 192.168 ... things, or 10 ... things, or occasionally 172 ... things, additional IP addresses. Those addresses will only ever be routed within local networks, and then we'll have a single device, a router that you either lease from their ISP or buy at Best Buy, that's going to itself have a unique globally routable IP address, and it's going to use what's called network address translation to basically represent all of the devices in your home network, business network, whatever your local network is, as a single publicly routable IP address, and it's going to, in a small way, abuse the TCP headers, the incoming and outgoing port information, to make sure that when, the traffic from my phone and my iPad and my computer all come out of what looks like the same IP address, when the responses come back, they go to the correct devices on my local network here. So that's all well and good. It saves IPv4 addresses. It saves the ISPs from having to, have a globally unique routable IP address for every single device. The problem is, of course, that if a device beneath NAT, underneath NAT, if my computer, my streaming software, my phone wants to make a connection to somewhere on the internet, say YouTube, right? That's fine, because I internally am initiating the connection, and then my router can say, okay, well, Jeff's computer with IP address 192.168.0.118 initiated a connection to YouTube, so I'm going to remember that, and when the response comes back to YouTube, I'll route it to Jeff's device. That's fine. The problem comes when things want to go the other way and talk to something behind NAT, right? If YouTube, for some reason, wanted to send data to me, they would say, okay, well, Jeff's router in his living room has a publicly routable IP address. I'll send some data to, I don't know what it is, 98.54. Whatever. I'll send some data that way. That data comes to the router, but the router doesn't expect to have any connections just sort of directed to it. It doesn't know where to send that data, to my computer, to my phone, to my Chromecast, to all the other virtual devices on my network. And so typically what it'll do is just swallow that information and say, this didn't come from inside, we didn't initiate the connection internally, I don't know what to do with this. It doesn't go anywhere, right? So in order for, say, a user out there, in order for, Nate out there on the West Coast, I believe, to connect to my Raspberry Pi here in Chicago underneath NAT as a server, I need to be able to accept those sort of, initiated externally connections. And this is where port forwarding comes in. I think Broke both mentioned this earlier. It can be kind of a pain, but basically what you do is you say, okay, any connections that come to any connections that I did not initiate that come to my router, that come to my publicly available IP address destined for a specific port. This is those same ports we saw in PuTTY earlier, right? Port 22 was SSH. Typically, port 80 and port 443 are for HTTP, like website style traffic, and the various other ports have by convention various other meanings. If a request comes to my router on port 80, then I want that request to go to this specific device on my network, right? It's saying, okay, even though I didn't initiate a contact, I know there's going to be spontaneous contacts from other places on the internet that are not going to know anything about how the network address translation works inside my local network. That's fine. In this one specific case, for this one specific port, I will tell you where those connections go, and that's what NAT is. So this is the thing you would have to configure in your router typically as a consumer, because that's where your translation is taking place. So this is going to be different for every single device and every single router. But looking at my admin account on my router, for example, which is a TP-Link AC1200, they're all roughly similar. They're all roughly different. Yes, I know my password is bad. In my router, for example, if I go down to forwarding on the side here, we can zoom this in a little bit, and it gives me the option to add a new virtual port. It says give me a port number, an IP address, and what internal port it should go to for which protocols and which statuses and so on. So basically this would be a way of how you might configure, say, the requests to port 80 that come into my public IP should be routed to a specific IP address on my internal network to port 80, right? So I would have my Raspberry Pi, for example, serving up HTTP on port 80, and if the public IP address gets a request on port 80, it forwards it directly to that device. Yeah, it's an awful password. It's really quite bad. Let's see what people say. Reverse proxies are also important. Yeah, bad passwords, that's kind of, could also set up one jump box instead of port forwarding for each device. Yeah, totally. Yeah, so instead of having like my laptop and my computer and my Pi all, have various requests forwarded to them, you would have them all route the requests through a singular device, and then that could sort of accept the outer traffic and do sort of do its own level of translation internally. A couple different ways to do it. Assuming we're setting up sort of a very basic Raspberry Pi system, maybe you're just doing direct like HTTP forwarding in from one port to another, or two ports, maybe it's port 80 and port 443. for HTTP traffic or something like that. The other thing you would have to set up, and again, like I say, I'm not going to go super in-depth down this route. I encourage you to look up more information from experts or solicit the advice of some of the experts who happen to be with us tonight, if you're interested in such things. But as a primer on this process, right, one of the challenges is that the public IP address, right, which is the IP address that your router is presenting to the world, is not constant, right? It itself can change from time to time, because your ISP might be rotating through IP addresses, it might be assigning you a different one or a different block. So you would use what's called a dynamic DNS service that would allow your router, right, when it is assigned a new when your router is assigned a new IP address, to inform other services of what its IP address currently is. And this is, for the example, like, let's say I wanted to buy the URL Jeff's really cool Raspberry Pi.biz, right, and redirect that so when you went to that URL, it served up some content from my Raspberry Pi to the internet to you, and you can look at that. I considered putting together an example like that for this evening, and then I didn't. But if somebody wants to buy Jeff's really cool Raspberry Pi.biz, it's all yours, right? There's no trademark on that as far as I know. I would need to tell the provider of that URL where my website is located. What's its IP address going to be? Where are the servers? GoDaddy. Where is this site actually living? And I want to be able to say, okay, they're at this IP address here, but my IP address, because it's being assigned from my ISP, my commercial service provider, it's going to change from time to time. So using a service, and my router actually lists a few of them here, DynDNS, so dyn.com, NoIP is the one I've played with a little bit before, or Comex, which I do not know, comex.cn, are basically all services that will allow you to, and many of them have a free tier of 3 devices or 5 devices that say, when my IP changes, I would like my domain name to automatically be pointed, usually with a CNAME command, pointed at my new IP address, so I can continue to serve content from that IP address. That URL can continue to point at the correct IP address. What shenanigans here? Let's see. Brooklyn is not buying $15 a year for Jeff's really cool Raspberry Pi.biz. That's how they get you. Yeah, you can't. Registering domain names is a slippery slope. I had like 3 domain names. I have Jeff.glass now. That's an expensive domain. I think that's like $50 a year I pay for that. But like Jeff.glass, come on, it's pretty good, right? So you would sign up an account on NoIP or DynDNS or what have you. And you would say, I would like to, every time my IP address from my ISP changes, please notify this service, and that will update your DNS records for you. That's the gist of that. If your router does not have this capability, or you don't have admin rights on your own router, which I hope you do, but if you don't, there are client programs for a PC, Mac, Linux, Raspberry Pi that basically run a server. They communicate with, for example, noip.com directly, right? It says, okay, I'm going to constantly sort of monitor, ask the internet what my current IP address is using an external service, and if it ever changes, then I will reach out to noip.com and say, hey, I'm Jeff Glass's Raspberry Pi. I'm now at this IP address, and NoIP again will take care of rerouting the DNS to the correct IP. So that's the gist of that process. And like I say, if you want to go down that road, I encourage you to. There are lots of links in the description that you can follow to do that, including the really important one about hardening your devices, a couple of links to using DynDNS or Dynamic DNS Services is the generic name to update your IP address as you go. Like I say, it's not something I necessarily always need to do. If you are just interested in having a server on the internet to play with, a generic server, a Linux server, I would encourage you to actually look at something like a DigitalOcean Droplet or an Amazon EC2 instance. It is going to be safer in terms of a security standpoint for a number of reasons, and easier, and probably in many cases cheaper than having your Raspberry Pi hosted. That said, if you're interested in like the very basics of starting to learn how to communicate with these things, and you have a Raspberry Pi, this could be a really fun project, right? Be fun to say this website runs on a Raspberry Pi that's on my desk, right? That's pretty cool. There are lots of other ways to do it, anywhere from like, I rent a server from Amazon for half a cent an hour, all the way up to I have 2 cabinets in a data center with terabytes and terabytes of storage in them, right? That hobby could span a whole gamut, but this is a little low-cost way that you could get into that if you wanted to. That's the gist of the dynamic DNS way of going through, sort of making your devices available on the internet. And yeah, Kenneth, I don't know what the verbal equivalent of a subtweet is, but that's exactly what that was. I should say, so I've been under, I think, 3 different primary ISPs in my time, and I have not run into this, but maybe others have. So I am familiar with NAT, right? Network address translation occurring at the interface from my router to my ISP, right? My router has a publicly available routable IP address, but I believe, and I'm told that there are situations in which that is not where the public IP is. You have sort of a commercial NAT, right? So there is a big router in your ISP's data center that is saying, okay, I am this globally routable IP, and it's assigning link local addresses or a non-routable IP address to a variety of its clients. So like your router would say, well, I to the outside world to this router am 192.168.11.79 with this port number. Carrier grade NAT says Kenneth is another layer if they need to. Yeah. So if you are running into issues serving content from your local Raspberry Pi out to the internet, it may be because your specific carrier has you behind like a commercial NAT system. Does that sort of track for those who are new to NAT how this is all breaking down? I should have gotten out my whiteboard paper, but here we'll do a hot fast diagram and then we'll wrap it up for the night, I think. And it's mostly because we haven't drawn any diagrams yet, and it feels like that would be a fun thing to do. So let's turn up the contrast a little bit here. There we go. So let's use some fun colors, because I didn't buy, a pack of 48 Sharpies 3 years ago not to use them. So let's see. Let's do that. Ooh, that's a little hard to see, huh? Go back to that. So here are my home devices. That's my computer. That's my Raspberry Pi. That's my phone, right? And they all exist on the network, and they all have non-routable IP addresses, right? So this one would be 192.168.0.4. This one might be .6. This one might be .118, what have you, right? Those would all be connected either wirelessly or wiredly to our router, right? Which in my case is that Linksys router we were looking at the configuration of earlier, right? Which itself has an IP address on our network just so we can configure it, right? This is 192. It's often, by convention, the first IP address in a range, 192.168.0.1, very common, right? That will have been assigned, he said, grabbing another color of Sharpie, an IP address from your ISP, your service provider, right? So this interface will have an IP address that generally is routable on the public internet. So this might be, I'm making it up, 98.40.162.71. So you could, if you knew my home IP address, and it's not this, but if it was this, you could ping it, right? You could send traffic to it, you could do whatever you want, and it would reach my router. But typically, because the connection was not initiated by a device inside of my network, it's not going to know which device inside of my local network to send that traffic to. So the NAT layer of my router is just going to swallow it. Now, if I've initiated a connection to, say, on the other side of the internet, through, some transit. I should probably use a different color for transit. Maybe transit is green. Through some big old pipes to the other side of the internet, to somebody else's. I'm going to call this I'm to make up a random string of numbers there, to a cabinet in a data center. Right? If they're in a data center, in this case, they might have their own publicly routable IP address by default. Right? They could be 14.7.96.17. And those two could exchange traffic. And if one of my devices, let's say my phone, reached out to this FCIX server, it could initiate a beat of communication. And in the data for that communication, inside of the TCP headers, it would sort of contain the information that my router needed, that when the response came back, it could come back to the correct device. And the problem with carrier grade NAT is this may not be the location where the public IP address is. This might be an IP address like itself, 192.169.4.7, and a bunch of other homes are also 192.169.4.7, and they're also using this embed some information in the TCP headers trick to put more than one home, more than one small local network onto a single routable IP address. This is all my understanding of the thing. Like I say, I've been fortunate enough that I've not encountered like that level of NAT translation in my personal abodes. But if you end up trying this out, and if you do, I want to hear about it. And you're having weird IP troubleshooting issues, it may be because you're behind network address translation that is just out of your control. So good luck. That's it. That's the thing. SSH, VNC, use the hostname.local MDNS setup to gain initial access. Let's go back and let's solve one last thing, which Nate provided an answer to earlier. How would you get VNC Server started if you didn't have a display set up? Sudo raspi config, says Nate. Let's give that a try. So let's come back to our... Oops, I moved my Raspberry Pi's keyboard out of the way. Actually, you know what? Let's say I moved my keyboard out of the way, but that's okay. We have a VNC. We have a shell connection to it. We actually can put that keyboard away. Let's come back over to, let's see. Okay, so we'll do sudo. So this is the Raspberry Pi that was not allowing us to open a VNC server earlier. So we'll do sudo raspi-config, and let's see. This is great. I'm just crowdsourcing my learning to y'all now. I hope you didn't think this was about your learning. No, this is my deal. Advanced options resolution. Advanced options. Experimental desktop GL driver. Network proxy settings. Let's go back. Display options? Resolution. Okay. So it will let me specify a default resolution. I wonder if it will now allow me to start a VNC server, or if it's still going to be grumpy because it doesn't have any actual display on it. I don't know. Let's find out. Would like to reboot now? Well, sure. You only live once. So that's going to kill my terminal session here. And I'll have to reconnect, but that'll be all right. Yeah, that should be fun. While that's rebooting, I'll give you the little updates on what's happening next week, which are... Oh, no, I won't do that yet. I'm going to tell you about one more command that's really useful. You can use this in the command line or in the terminal, and that's ping. Our old friend ping. I'm going to open up the command line in Windows here, but the command works basically the same on the terminal. You enter ping and either a host name or an IP address. In this case, actually, I'm going to specify the -n argument and ping it a certain number of times. That's going to be a really easy way for me to tell whether that device has come back online or not. But of course, if I use the host name, it can't find it. So we'll do this by... Interesting that it fails immediately if it can't resolve. Because if you do this by IP address... 192.168.1.118, I think? It will fail 1,000 times now until the thing comes back on. But what I really wanted it to do was fail 1,000 times trying to identify this MDNS address. Well, the more you know. I guess I will give you the updates on what's happening next weekend, which will be another Demi-Light weekend. So I mentioned this to some people who popped in yesterday for the surprise LEDs stream. The new circuit boards for Demi-Light version 0.9.5 are showing up on Tuesday, according to DHL, which is great. Sometimes they show up a day early, so I'm very excited about that. So we'll get to play with those a little bit, see if that works, see if that new method of getting the bootloader onto those boards and programming them over the serial port works as well as I hope it does. That shipment from DHL also contains the first prototypes of... as we were looking at last time. Oh, snap. First prototypes of ripping your audio interface just right off the desk there. Oh, I'm frozen, Jeff, again, aren't I? But I think you can still hear me. Oh, what have I done? Hello, I'm not frozen over there. I'm only frozen over here, which means... What does that mean? Which USB hub came disconnected? What a way to end. What a way to close out the evening. Here, hang on. We'll get my face back, and then we'll just in time for me to wave to you nice folks as you head out. Let's see. Activate. There we are. Well, good. I can be blown out and overexposed for the rest of the evening. Here, maybe I'll just adjust the color temperature because I have feelings about color temperature on video. There we go. Color temperature, backlight, contrast. Turn the gain down. There I am. Hi. Wow, that was. I don't know why. I don't know why anything. So we'll play a little bit with the prototypes we made last time for the display and control units for the Pocket RDM unit. So that should be a working end cap and button unit, but just a prototype, like a fitment type PCB for the control board itself, right? We didn't actually finish designing that. I just wanted to order a cheapy one so we could sort of test it for size. But hopefully we'll be assembling the first version of like display and control system for this next weekend, which I think will be quite a bit of fun. That version does have the 2-button interface as opposed to this joystick interface that we came up with last time, just because of when I ordered it. But I think that will be, I think we'll learn some things about fitment and we can replace it with the joystick later on. And then the new 3D printer should be here, and we'll get to work printing version 0.95 and hopefully getting the fitment all right on that. Okay, we've booted into our. We can see our ping is resolving, so we've found our device. Let's SSH back into our Raspberry Pi.local. Doing a stream of building a machine. Chris, I got mine pre-assembled. I did not get the kit. Let's see, Pi VNC Server. We'll see if this works. And we'll launch our VNC client, and we'll do Raspberry Pi.local. Interesting. So I set a forced resolution, but it doesn't have a display. You might have to launch like an X Windows Manager manually, which is like the subsystem that lies underneath the display system in Debian, in GNOME, in the display manager, I believe. This doesn't seem to quite be doing it. So I guess at this point, and sure, somebody do some research and tell me next week, but it seems like SSHing in would be relatively straightforward. Getting a remote GUI going without an attached display, not as straightforward. But maybe I'll do some research and we'll figure it out together. Ooh, what was happening there? Ooh, yes, this is what I mean about the Raspberry Pi being grumpy about video display when it gets rebooted. Ooh, yeah. Let's see. Ooh, Nate's printer made it to the United States. That's very exciting. My color temperature has reset. That's also very exciting. So Brookboy, so I and Chris and Nate should chime in with what they got, because I think they got similar things. I got a Prusa Mini Plus. I meant to order a Prusa Mini, and then right before Thanksgiving, they came out with the Prusa Mini Plus, which is the same thing, but with a slightly newer firmware and a better bed leveling sensor, that super pinned up sensor. We have a Prusa Mini original at work, or actually right now it's at my boss's house because we were being shut down for a little while. But I having tasted how good the Prusa products are, and Nate got the i3 Mark III. I think Chris did as well. They're just so much more reliable, and I don't think I have even kept them, but like I was making some little demo prints, like some demo, anything come unplugged that I care about? No? Sound is still there? You're a bit crackly? Yeah, I tripped over my own microphone cord. Maybe we'll go back to wireless ones someday. I was playing with like embedding magnets into 3D prints. This was my little side project this week, which worked quite well. Of course, that's aluminum. Like even like you can see the amount of brim I had to put on this, and the post-processing and the print quality is not great. And just having seen how good the Prusas are, I just bit the bullet and bought myself one. And it's got a place of honor just... Oh, that's going to be awfully bright. Let's get that light out of the way. But that's its Dexter-like tomb that it's gonna hide in up there. That cacophonous setup with what looks like a Kodama, although I think it's just a lamp hiding in the corner there. So it's just waiting for me. It has not shipped yet. It seems like shipping is a little bit behind schedule for the Prusa Minis. So hopefully we have that by next week. Maybe not. But yeah. Either way, we'll have a good time, and we'll build tiny moving lights. I'm with the Prusa in place. If 0.95 works, like I think I've said this like 17 times before, but I think we're really close to like doing a run, like just 10 of one board, of one design, of one light, and having a show. I think we could do that with 0.94 if the Prusa was here, but if we're gonna do it with 0.95, we might as well just do it, and that'll be great. Yeah. That's all I got this week. I certainly learned something this week. I hope you did too. And clearly, like I say, not an expert. I hope the links below are helpful. I hope the people here have been helpful. They certainly have been to me. I have some stuff to go check out now and some problems to solve. Y'all are great. Please be safe out there. Please wash your hands. Please wear a mask. You know all this stuff by now. Keep hydrated. Get good sleep. Yeah, y'all are great. It's a pleasure, as always, to spend these Sunday nights here. We'll see if there's any more impromptu streams the next week. I get the feeling like part of the reason I did one yesterday was like I'm coming down to the time when I'm going to have to be at work physically a lot more and just more tired, so maybe I'm trying to have lots of last-minute fun before that pops off. So we'll see if there's any more bonus streams in our future. But either way, I will be back next week at 7 p.m. Central Time here on YouTube. If you want to be reminded that that's happening, subscribe and like and bell and all the things that people tell you to do on YouTube. And thanks, you wonderful nerds. I will see you next week. Bye.